This is a Bosch Rexroth EFC5610 Inverter Drive, and this is a ctrlX Core X3. In this video, I'm going to show you how to add additional data to the EtherCAT device profile so we can read output frequency in real time. Hello, I'm Simon from the Inverter Drive Supermarket. In the previous video, we created a program and visualization to control the EFC5610 over EtherCAT using ctrlX PLC Engineering. The visualization included a meter to show the setting frequency from the drive, but it would be far more useful if it displayed the output frequency. The standard device profile doesn't include output frequency, so we'll need to add it. We can do that using ctrlX I/O Engineering. I'm going to load and edit the demo I/O project we created in the EtherCAT video. If I double-click XFC01 Rexroth mode, select the General tab and enable Expert Settings, a few additional tabs appear. The one we need is the Expert Process Data tab. There are 2 transmit and 2 receive PDOs listed. As you can see, the standard values are in the 5s. I'll leave those as they are. This view is from the perspective of the EFC. What I want to do is transmit the output frequency, so I'll select TX PDO 22. Then I'll click the plus button in the PDO content box below. Here's output frequency. If I expand it, you can see it's read-only, so there's nothing to worry about on the receive side. When I click on the data, all the required information is populated automatically. Nice and easy. Click OK to add it to the content. If this expert process data section is useful and you want more practical ctrlX and drive integration tips like this, consider subscribing. That's exactly what this channel focuses on. This change updates the device profile, so now I need to right-click EtherCAT Master and download. Log in using your usual Core X3 credentials if prompted. The EtherCAT bus on the X3 needs to switch from operating to initializing so it can apply the update. This transfers the updated configuration to the X3. If I also save the project, it transfers that to the X3 too. We're done with ctrlX I/O Engineering, so can switch back to PLC Engineering. Open ctrlX PLC Engineering. Before making any changes, I'll stop the application. The first thing we need to update is the data layer. Right-click Data Layer Real-Time and select Real-Time Data, then selectively from ctrlX Core. Log in if prompted. Change the Select a Real-Time Node drop-down to EtherCAT Master Instances EtherCAT Master and expand XFC01 Rexroth mode. You can now see output frequency listed, but it isn't selected. Check the box, then click the Transfer button in the middle to update the PLC project. Click Close. Now that the I/O is mapped correctly, we need to add a rung to convert the raw data into a scaled value we can actually use. Right-click in the W Setting Freak rung and select Insert Network below. Right-click on the new rung and select Insert Empty Box with Enable Output. Name it Word_to_real. Delete the contact, we don't need it. Assign W Output Freak to the input. And in the Auto Declare dialog, set the type to Word and initialization value to 0. This represents the raw output frequency value from the EFC. Assign R Output Freak to the output. In the Auto Declare dialog, set the type to Real and the initialization value to 0.0. We've now converted the raw input value into a number. However, as before, the resolution is 0.01, so we need to divide this number by 100 to get the value in Hertz. Right-click and insert another empty box with Enable Output. Double-click the name and click the ellipsis button. Make sure the Text Search tab is selected and enter div for the divide function block. Then double-click div in the results to select it. Set the inputs to R Output Freak and 100. The output can also be R Output Freak. There's no real advantage in adding another variable. The ladder logic is now updated, but W Output Freak and R Output Freak still aren't mapped. So let's fix that. Right-click XFC01 Rexroth mode and select Edit I/O Mapping. There is the new value, but the variable is empty, so let's assign it. Double-click on the space, then click the ellipsis button. Select the Categories tab, then expand Application, EFC, PRG EFC01, and select W Output Freak. Click OK. Now we can return to the visualization and update the meter. Click on the meter and double-click the value near the top. Click on the ellipsis button, select R Output Freak, then click OK. I'll also update the label to reflect the change from setting frequency to output frequency. I'm going to add a rectangle to display the setting frequency instead. Another meter could be confusing. As before, we can display the variable in line using %s so it's clear what this is. We can then bind the text variable to our setting freak using Input Assistant. Now let's try it out. We're using our EFC5610 drive and Core X3 demo rigs as in the previous video. First, click Online, then Log in. We've changed the PLC program on this laptop, so we need to download those changes to the X3. Click Yes when prompted. Right-click Application in the project tree and click Start. Click the button to set bit 7 active, instructing the drive to accept a command. Then click Run and set the frequency. The motor accelerates as before. Now, when we change the frequency, the meter reflects the actual motor speed, so we can see it accelerating and decelerating in real time. This is really clear when we change direction. The motor first decelerates to 0, then accelerates back up to the setting frequency in the opposite direction. We can also see it follow the deceleration ramp when we issue a stop command. Perfect. That's it for this video. In the next one, I'll show you how you can use the Core X3 to control a different brand of drive. Thanks for watching. I hope you found this useful. If you did, please give it a thumbs up and consider subscribing for more practical ctrlX and drive control content. See you next time. This video is for educational purposes only. Always follow official manufacturer documentation and safety instructions.